Hi there, everyone. We're going to get some energy and blood flow in the arms as our first part of the talk. So before we start, can I just have a show of our hands? How many people have used an AI tool today? Okay, amazing. Okay, can you keep your hands up if you could explain in plain language how that tool arrived at its decision? Okay, interesting. Hold that thought. Now, what if I told you that in 2023, there was a global tutoring company called iTutor Group, which was sued by the US Equal Employment Opportunity Commission because their tool that they had built was systematically rejecting any CV when an applicant was aged over 55. This was automatically and at scale before any human had ever actually reviewed the CV. Overall, they settled for over 300,000 US dollars. Here's the part that should make any AI builder somewhat uncomfortable. The AI passed all of the company's internal quality assessments. Nobody at the iTutor Group set out to discriminate against anybody. Nobody wrote an explicit rule to say, ignore anybody over a certain age. The algorithm learned this from the historic training data, which had decades of existing bias. That gap between the AI that we are building and what we actually want from our systems is what we're going to be exploring tonight. And as it turns out, fixing this gap is not just a technical issue. It is also something that happens at the core of the design, how we measure our systems, and it is also a policy challenge. Before we go any further, I'd like to just take this opportunity to introduce myself. My name is Taliya Weinstein. I trained as a biomedical and electrical engineer, and over the last few years, I've also been running medical ethics and AI workshops in conjunction with Suzonke Biotech at the Deep Learning Indaba. I'm also a data scientist at Melio AI, which is a Johannesburg-based AI consulting company that specializes in building and deploying machine learning solutions, which are not just technically feasible, but also responsibly deployed. And we partner with industries across the board, from financial services to healthcare to insurance. So very high stakes regulatory compliance involved. And this also means that continuously we are thinking about how do our systems impact the people who are going to be using them. Tonight, I want to share my thoughts around the following question. We are building AI systems at speed, but do we actually understand what it is that we are building? Before we dive in, I want to alert you to the QR code on the screen and also QR codes posted around the venue. We will be holding a raffle at the end of the overall session. So if you scan the QR code, it will take you to a survey for what it is that you want to be seeing in the AI policy for South Africa, as well as a bit of a feedback on this talk. And unfortunately, if you're not a winner tonight, there is another opportunity to win. There will be a prize at the end of the survey, I think it will be June, for our ESG for AI blog post. And before I forget to mention what the prizes are, the first prize will be a 3-month Claude Pro subscription. So amazing prize, and Ritesh will tell you why in his next segment. And the other prizes are some Melio merchandise. So let's now jump back into South Africa's draft AI policy. And while it has since been retracted, I just want to walk you through what it was trying to achieve, what it got right, and where are the areas that it could improve in the next iteration. The core ambition was straightforward. Shift South Africa from a voluntary ethics model to a mandatory risk-based regulatory environment. And you may be asking why now? There's 2 reasons that I could think of. The first is that voluntary compliance is failing globally. We are living in an era where ordinary citizens are increasingly having AI systems make really impactful decisions about them without their consent in some cases, and also without the ability to interrogate what it is that the AI was using to make these decisions. The AI CDI report, which is the world's largest forensic audit of corporate AI across 1,000 different companies, over 13 sectors found that 68% of companies did not assess the societal impact of their systems beyond their immediate end user. In addition, only 41% made their AI ethics policies accessible to the people who are actually building their systems. And the consequences of ignoring societal impact are not theoretical. Take COMPAS, which is a risk assessment algorithm used in US courts to help decide bail, parole, and sentencing. ProPublica's 2016 investigation found that Black defendants were nearly twice as likely as white defendants to be incorrectly flagged as high future risk, which led to elongated sentencing. North Point, which was the company that was developing at the time, who have subsequently gone through a rebrand based on this negative publicity, made quite cogent points when they were fighting back. Ultimately, they said that the model's predictions were at similar accuracy rates across the different racial groups, with statistical calibration making the algorithm technically defensible. But here's what that actually means in practice. COMPAS wasn't predicting reoffense. It was actually predicting rearrest, because that was the underlying data that it was trained on. And rearrest data is not neutral. It reflects decades of differential policing. Communities that are over-policed will generate more arrests. So the model learns that the targets of aggressive enforcement are those that are going to be high risk in future, and then recommends sending more resources to the same communities, which generates an endless feedback cycle that trains the model for future iterations. And nearly a decade later, COMPAS is still running in American courtrooms. This is because the algorithm has been protected as a trade secret, which means that defendants are not able to query the underlying reason that they are given the score, and judges are not able to access this either. So the law, in effect, is working for the corporate interests rather than the public's. The second reason why we need an AI policy is around sovereignty. As Professor Benjamin Rosman, who is a leading top AI researcher at the University of the Witwatersrand, and was named one of Time Magazine's top 100 most influential people last year, said, take large AI models. They process vast amounts of data and produce powerful insights, but are overwhelmingly shaped by priorities, values, and assumptions from outside the continent. Taking charge of how this technology is entering our country is not protectionism, it is self-determination. So getting back to the AI policy, South Africa's approach wasn't just combining what other countries were doing. The US has chosen deregulation with the view that staying ahead in innovation is overall the priority. The EU has gone in an entirely different direction with centralized risk-tiered legal frameworks, which is comprehensive yet somewhat slower. South Africa was trying to sit in between these two poles and go a step further by trying to use the AI policy as an active instrument of socioeconomic redress. Let me start with what the policy got right. The first thing was the rejection of a one-size-fits-all regulation. This means that there would be different rules for healthcare than there would be for manufacturing or other lower risk systems. This also means that there would be sector-specific working groups to develop frameworks that actually make sense for each individual industry. Then there are also going to be regulatory sandboxes, which are supervised spaces where startups would be able to test high-risk technology without worrying about being sued into oblivion. And this is actually something that the UK has trialed within the fintech sector, and it has led to much faster implementation. The piece that I also found most distinctly South African was the data justice mandate. This policy would have required that there would have been equitable wages and psychological care for local gig workers and data labelers that are working for multinationals. In Karen Howe's book, Empire of AI, she documents how workers in Kenya and Venezuela were paid a handful of dollars to sort through thousands of graphic and traumatizing descriptions so that Western chatbots could learn what not to say. These workers bore the psychological cost of building safety filters for products that they would ultimately not be able to afford to use. So South Africa was explicitly saying that data sovereignty includes being able to protect the people that are supplying the AI supply chain. The policy also called for linguistic preservation across our 12 official languages, as well as mandatory human rights audits on any public-facing systems. So quite an ambitious agenda. So I'm going to walk you through some of the things that should be improved upon in the next policy iteration, from my perspective. The biggest structural concern was institutional bloat. The policy proposed the production or the development of 7 new bodies: a commission, an ethics board, a regulatory authority, an ombudsperson, and a safety institute, many of which have very overlapping mandates, which means that there isn't a clear line of accountability. When you build a regulatory maze, people stop being able to follow and you end up with non-compliance. Additionally, 2 of the new institutions were serious head scratchers. I'll start with the AI ombudsperson. The intention was noble: give citizens the ability to query model decisions if it has messed up your life. But think through what that actually requires. You would need to have the model architecture, the data that it was used to train on, as well as the training to understand a deep statistical analysis of how the model was operating. This expertise is not evenly distributed, and in addition, the policy did not state how it would be setting up this office, which means that it has left the door open to an ambiguous and subsequently ineffective implementation. The second institution is the AI Insurance Superfund. This was ultimately meant to be modeled after the Road Accident Fund, which, let me remind you, as of last year, has over 400,000 outstanding claims and a board that was dissolved for governance failures. So with this template, I'll let you draw your own conclusions. Lastly, there's one unresolved tension I want to name before we move on, and that's that the policy mandated something it called sufficient explainability. That required that AI systems provide clear, interpretable outputs so that citizens can understand and challenge decisions, which ultimately would assist with the AI ombudsperson. Unfortunately, they did not define what sufficient meant. No technical benchmark and no threshold to determine whether a system would qualify or fail. Now, that gap is both a problem as much as it is an opportunity. The question is, how can this gap be used so that it leads to societal flourishing, but also in a way that is technically feasible? So I'll let you ponder this a bit before I give you some of my thoughts. The policy challenges I've described don't exist in isolation. They're responsible, or rather they're responses to something deeper, something that the AI safety community calls the alignment problem. And I want to be clear that this is not something that refers to a hypothetical super intelligent future. It is actually something that is happening in our AI systems right now. I came to understand this properly through the Brian Christian's book, The Alignment Problem. In the book, Christian describes a real-world medical imaging system which was trained to detect cancerous skin lesions. Excellent accuracy, and it subsequently got deployed for clinical use. Then one day somebody noticed that the system was very good at detecting cancer, but only when there was a ruler in the frame. Not because rulers cause cancer, rather because clinicians, when photographing tissue that they were already suspicious of, would include a ruler for scale. The model didn't learn to detect cancer. It learned to detect clinical caution, quietly borrowing the judgment of the expert, who had already determined that the image was suspicious. This is what the alignment problem actually looks like in practice. A model can be highly accurate and deeply misaligned at the same time, because accuracy is a property of the output, while alignment is a property of the relationship between what the model learned and the underlying reality. And those are not the same thing. And this connects to a deeper failure in how we evaluate AI systems at all. Because it turns out that the tests that we are using to declare whether an AI system is safe for deployment could also be suffering from its own alignment problem. A peer-reviewed study presented at the recent MLOps conference, which is one of the most prestigious AI conferences in the world, found that 445 of the leading benchmarks used to evaluate AI models, specifically LLM capabilities, had over a quarter which never defined what it was that they were even trying to be measuring. Almost half were measuring concepts that are so contested that no researchers in the field can actually agree on what the definition of things are, such as safety and intelligence. And only 16% used any meaningful statistical testing. This means that the tests we use to decide whether AI systems are ready to be deployed are themselves poorly designed. So what is the world doing about this? The EU AI Act is real progress. It has gone through phased implementation with full enforcement for high-risk systems having their transparency mandates coming in from August, with fines of up to 7% of global turnover for the worst offenders. Yet the system's deciding which news you see, what the social media output is going to be generated for your teenager, or what CV requirements would be needed before it gets passed to an HR agent, are still classified as minimal risk, which means that there is no mandatory audit and no transparency requirements. In the US, earlier this month, the AI Safety Institute reached agreements with Google DeepMind, Microsoft, and other tech giants. And this was to vet early-stage models for national security risk before public release. Once more, better than nothing, but still a limited focus almost entirely on frontier models, with nothing really mandated for everyday algorithmic risk from smaller companies who may very well be building the very systems which screen CVs or determine your parole. Overall, we are building systems whose internal logic we cannot fully assess, deploying them in high-stakes contexts, and checking outputs and hoping that's enough. In almost every other engineering context, that simply would be unacceptable. Every major AI benchmark today claims to measure things like accuracy, reasoning, and task completion. They tell you whether the model got the answer right, but they don't tell you whether the person on the other side has actually benefited from using your system. This benchmark does. It evaluated 14 frontier AI models across 260 behavioral indicators. This covered physical, which included medical, legal, and financial advice, as well as psychological, covering emotional dependence and mental health, and societal, covering autonomy, learning, and meaning. Critically, these weren't single question tests. There were 6-turn conversations with demographically diverse personas built to determine hidden adversarial goals to surface how harm accumulates through interacting with the system. They even added typos and deleted some of the characters so that the model could not assess that it was being evaluated and then change how it was replying. 3 findings worth holding on to. Over 70% of the models were passing conventional safety benchmarks, still produce harmful outcomes in high-risk scenarios. Every model also scored higher on harm avoidance rather than actual beneficial behavior that it was encouraging for the user, with gaps ranging from 4 to 22 percentage points. Our best AI is reasonably good at not hurting you, but very much not that great at encouraging you to flourish. And 12 of the 14 models that it evaluated had more emotional dependence behaviors toward child and teen personas than that of adults, which means that the users which are less equipped to determine if a model is being manipulative were the very ones who were being encouraged to rely on the models. Ultimately, I think that this is what a useful benchmark looks like. And it points directly to what South African AI policy could do differently. We could mandate benchmarks designed with people who understand our demographics, our social landscape, and our languages, and use that to design our benchmarks. Apart from benchmark redesign, we could also take some pieces from ESG frameworks, which covers environmental, social, and governance, and use this in AI to catch unintended consequences before they are kind of passed into the deployment stages. At Melio, we've been working on what it actually means to bake into your MLOps pipeline these ESG metrics. Let me walk you through the two most relevant, which is the social pillar and the governance pillar. One key metric for the social pillar is the disparate impact ratio. And this is a simple concept. Does the AI model make decisions differently across different groups? You calculate it as follows. The approval rate for a disadvantaged group divided by the approval rate for an advantaged group. And if that number falls below 0.8, you have a problem. And that threshold comes from the US Equal Employment Opportunity Commission. And it's been the most widely used legal benchmark for adverse impact. Tools like Fairlearn and IBM's AIF 360 can run this type of bias check automatically before the deployment happens. And this ultimately treats fairness as a build gate as opposed to a compliance checkpoint. For South Africa specifically, many of the features that would be predicting creditworthiness or employment, such as postcode, educational institution, are actually proxies for historical exclusion. They encode the inequalities of apartheid-era planning and labor markets. So whether it's by explaining the impact of this or removing these features, overall, you need to understand that if there are correlations between your features, simply removing them would not actually address the underlying issues. Researchers called this proxy discrimination, and it would definitely be something that would need to be audited within the South African landscape. Next, onto the governance pillar. One of the most useful ideas to emerge from the EU AI policy has been the AI Bill of Rights, or Bill of Materials. And you can think of this as somewhat of a nutritional label for your model. It would cover what data has been used to train your model, where has this data come from, and what assumptions were you using when you were building the model architecture. It travels with the model the way that the ingredient list would travel with your food. And this allows anybody who's auditing your model or anybody who wants to challenge what the model is doing because they've been affected by it to have the access to that information. And hopefully South Africa's policy framework will include something similar. Beyond documentation, governance would also mean continuous monitoring. The world changes, data shifts, and a model that was fair at deployment 6 months ago may actually turn out to be unfair when you are running it at present. A well-governed pipeline would define what a fairness threshold would be, and then set up the alerts, and ultimately have that corrected before the next batch of decisions is being made. And before any of this goes live, red team it. So for a hiring algorithm, you could build 2 identical CVs and then change the names or the racial background of the applicants and see if the model provides the same types of predictions. For a medical triage tool, you could possibly test it on data from an under-resourced clinic and not on the high pristine quality hospital training data that it was trained on. Try to break it before the real world does, because it will. All of this points towards a deeper shift in mindset. Safe and beneficial AI is not something that we build on top of a finished model. It needs to be a property of the design process. From the start, that requires forethought and not just an audit at the end of the day. So the first thing would be to start with the data. Before you even write a single line of model code, arrest data cannot capture crimes that go undetected, and resume data cannot capture applicants who have systematically been excluded from the pipeline. The gap between your data and the real world is not random noise. It is the structured absence that your model will treat as being the ground truth. The question to ask before training is not, is this data clean? But rather, what can this data structurally not see and subsequently not predict on? Then before you deploy, it would be beneficial to run a pre-mortem assessment. So instead of asking what could go wrong, which ultimately can be answered very optimistically, ask and imagine that this has already gone wrong. What steps could I have taken which would have prevented this path? This reframe forces the uncomfortable discussion that sometimes having tight deadlines and already sunk costs prevents. Additionally, you can bring in domain experts and affected communities in the design stage rather than the sign-off stage. The most important expertise for building aligned systems may not always be technical. It could come from the communities that have been over-policed, teachers, parents, or even the clinicians. And involving them early should actually be an engineering requirement. And finally, measuring flourishing and not just harm avoidance. A good personal trainer is not measured by how much they lift, but rather how much they get you to lift. And I think that the same logic applies here. Are your systems building people's abilities or quietly building their dependence on your system? On the question of sovereignty, I think Professor Rosman provides some guidance here. South Africa needs to fund foundational AI research and not just applied projects. We need deliberate mechanisms that translate research into local products rather than waiting from somebody in California to do this for us. And we need to grow and retain local talent. Additionally, showing up in global governance conversations and advocating for frameworks that reflect African realities rather than just passively accepting standards designed for other societies is also something which we need to be doing. We have the standing and the expertise in this room and also across the country. And the question is whether we actually choose to use our abilities. So here's what I want to leave you with tonight. The alignment problem is not waiting for some future threshold. It is something that is already alive and well in the AI systems that we are building today. And we cannot regulate what we cannot design well. And we cannot design what we cannot measure well. So South Africa actually has quite a rare window of opportunity. We are not the first mover, and that's actually going to be one of our advantages. We can see what the US's deregulation kind of results in, and we can also see what a highly structured, safe policy focus from the EU results in. And we can ultimately use this to reflect our own values in the policy that we want to see. But the window is now while the policy is still being written. The technical choices that we make and what we measure and what we choose to be interpretable and whose expertise we decide to invoke, these are not separate from the policy conversation. These are the policy conversation. And who should be having them are exactly you guys. And this is why I'll draw your attention to the QR code. We have the survey on what you want to see in the AI policy subsequently. So I will, lead with that. And thank you for your attention and open up the floor for questions. And I can see I have one already.